a good day. So today we are going to I'm doing a recap on this question of dynamics. In this equation, you are given a system there, and this is our system. And in our system, we can see that we have the acceleration is going this direction. So when the acceleration is going this direction, that means that the motion is going in this direction. It means our system is going like this. So our system is moving like this. Yes, this can be possible because this mass can be bigger than this mass, and it cause the system to move like that one in this direction. So in this question, the first thing that we're going to do is to identify the forces which are acting. We need to identify the forces. How do you identify the forces? Because there is this, we have been told these are the secrets of BSc. If they say this is a rope or this is a string, know that this is tension. Rope, this is a string, this is tension. These are the secrets that you need to know. And because this body is on top of a surface, it is going to exert this weight force. And the weight force, when there is a weight force, whenever there is a weight, it means there is a normal force. The normal force is the force acting against the weight force. And according to here, the normal force is going to act up. And this is a secret of BSc that you need to know of physics. This force, it is always, questions, most of the time, is always the mg cos theta is always opposite the normal. And this force is always acting down. You can go to mass 2. This is a normal because there is a weight of m2 there. And this force and this force, they're going to do what? They are going to be act opposite. Because this mg cos theta is always acting opposite. Mg cos theta is always acting opposite. It's always acting the opposite. And this force is going to act what down. Mind you, this force and this force, this is you have resolved your m2 there. So ladies and gentlemen, should you know that because they're told that the motion is moving this direction. If this mass is moving, there should be a force against it. Going against it is also a friction. So whenever there's movement, there's what? There's friction. There's frictional force. This mass is moving there. The friction is going to act down. That's why here we are saying that there is friction on mass 1. There's a friction in mass 2. So let us just come up with a question. The question they can ask us to find the acceleration. This is the question number 1, to find the acceleration. And question number 2, they can just ask us to find the m2 which will keep the system at rest, provided that your theta 1 is 23 degrees, your theta 2 maybe they say is 25 degrees, and they say that your mass 1 is 5 kg, and they say that your UK1 is 0.2 and your UK2 is 0.36. This might be some questions which can exist. So from here we are going to do what we call interaction of the forces. I like to tell my students that there's what we call interactions of the forces. Interactions of the forces. What are the interactions of the forces? In this system, we should know that this force and these forces are interacting. You see, these forces are what? Are interacting. And these forces are what? Are interacting. Therefore, these forces are what? Are interacting. and also these forces are what? Are interacting. I know it's someone is untidy there, but we can. Let me bring another paper here and say, don't mind this diagram, don't mind the diagram. So before, as we can see the interaction of the forces, it means we can draw the free body. We can draw the free body diagrams. We can draw the free body diagrams. How can we draw the free body diagrams? When we draw the free body diagrams, this, you can see this mass here. This mass is in a slanting surface, so it needs to be slanting like this, and say this is our mass 1, we have our tension there, and this is our m1g sine theta, and this is our normal 1, and there's a force going there which is fk1, and there's a force going there which is m1g cos theta. And don't forget to show the direction of what? Don't forget to show the direction of what? Of the acceleration. You can see that this is the direction of what? Of the acceleration, because we say that our system is moving like this. Our system is moving like this. Therefore, to draw the free body diagram of second mass, it is also slanting. Here is our tension, and we have two forces going there. We have fk2, and we have another force. Mind you, this should be a straight line like this. We have the other force going there which is n2, and we have another force going there which is m2g cos theta 2. This, mind you, this is theta 1. I'm sorry for that. This is theta 1. This is theta 2, and we have m2g sine theta 2. Now, after here, you can see that interaction of the forces, that now these forces are interacting, and also these forces are interacting, and these forces are interacting, and also these forces are interacting. Now we are going to draw the equations of motions, or equations of motions which are happening there. And looking at this first interaction here, that we have 1 interaction, 2 interaction, 3 interaction, 4 interactions. It means we're going to have 4 equations of motion. So looking at this equation of motion, this one, we have n1 minus m1g cos theta 1, and it is mass. The acceleration is 0. Why? Because this is an interaction in the y-axis, and this body was not moving up, it was just moving on top of the surface, meaning that there is no force pulling it up or down, meaning that the forces here, these forces are balanced, because they are balanced, and the acceleration is 0. Because they don't cause a movement here, it means you're going to have n1 is equals to n1 is equals to m1g cos theta 1, and we can say that this is our equation 1, and this shows that we have this such an interaction here, and I pointed out that is this interaction. Another interaction is this interaction, another interaction, this interaction, and our system is moving down. Here I forgot to put the direction of the acceleration, meaning that the acceleration is going this direction there, because actually our system is moving in this direction. So this interaction is going to be, because the acceleration is moving here, a secret is, because if this object is moving down, it means this force is greater. This force is greater. Means that's going to be m1 g sine theta 1. You minus the tension, which is the tension there, which is the t there. You minus the fk1. You still have the acceleration at mass 1. So this becomes our equation number 2. That becomes our equation number 2. And you can see that from this free body diagram, we came up with the 2 equations, meaning that we had 2 interactions which are taking place there. So let's move on. Consider another equation there. We have this interaction. You see it. We have this interaction. I hope you see this interaction. It means we have N2 minus M2G cos theta 2 is equals to M, and this is 0, and that means that our N2 is equals to mg cos theta 2, which is equals to and this is equation number 3. This is interaction number 3, and the last interaction, because the things moving like this, it means here tension is greater. Even if you can minus m2g sine theta 2, you can minus fk2, you still in at mass 2 you have the acceleration. This is equation 4. You had 4 interactions, it means 4 equations. So 4 interactions equals to 4 equations. So if you have 3 interactions, you're going to have 3 what? You're going to have 3 equations. And I'm going to make sure that I do all these equations of dynamics. From those 4 equations, therefore, I hope you can see them. From those 4 equations, which equations contain acceleration? It is equation what? It's equation 2 and equation 4, that the equations which contains what? The acceleration. Meaning that we are going to consider equation 2, which is m1g sine, theta 1 minus t minus fk1 is equals to m1a, which is equation 2, and equation t minus m2g sine theta 2 minus fk2 is equals to m2a. They have the acceleration. Mind you, the equation which we wrote there, it was find the acceleration. What do you do there? We have, when you find the acceleration, this is a secret. They'll put t in BSc general. Make sure that you just eliminate that t. And how do you eliminate the t? You make the t subject. You make the t subject of the formula. You make the t subject of the formula. So after you make the t subject of the formula, if you make the t subject of the formula in equation 2, look at this t is what? The t is negative. So if the t is negative, you take this negative t, you put this side, you take this m1a, you put that side, meaning that your t is going to be what? Your t is going to be m1g sine theta minus fk1 minus m1a, and for equation 3, your t is positive. You're going to take all this side, all these things, you put it that side. So your t there is going to be m2g sine theta 2 minus fk2. I'm sorry for that. So it's going to be plus, this is going to be minus, and this is going to be plus m2a, because I had to take this side and I put it. Yeah, but yeah, it's okay. I have to take this guy, and I put it that side. Then what do I do next? I'm going to equate my my t. So this t, the first t, I'm going to equate it with what? With the second t. I'm going to equate it with the second t. I'm going to equate it with the second t. I'm going to equate it with the second what? T. After here, I can find my acceleration. What do I find it? I make a the subject of the formula there. Mind you, they can say, they can give you a condition, say in terms of UK. When they say in terms of UK masses and mass and all this, it means you have to substitute this guy, and substitute this guy, it means at that point I'm going to put UK1, and you put what is UK, this force UK, we know that FK is equals to mu kn. So what was our n there? Our n at 1 was this guy, meaning that we are going to say FK1 is UK1 m1g cos theta, and our FK2 was mu k n2 which is equals to mu k. What was our m2? Our m2 was m2g cos theta 2. It means that in that equation here we are going to substitute our fk1, and after substituting our fk1 we substitute our fk2. Let us substitute from that equation there. When we substitute fk, we are going to have such an equation. Cos theta 1 ma equals to m2g sin theta 2 plus mu k2 m2g cos theta 2 plus, there we have m2 plus m2a there. Then what do? We make a the subject of the formula. After you make a the subject of the formula, we can do all other things. So for the second part of the equation, they say that they say that you should define the m2 which will keep the system at rest. So the m2 that will keep the system at rest, it means that our a is equals to 0, our acceleration is equal to 0. Therefore, if our acceleration equals to 0, it means for question 2, because our acceleration is equal to 0, we are going to take that equation which we have made a the subject of the formula, and is an exercise. You make a the subject of the formula from this equation. After you make a the subject of the formula, from that equation you are going to say the a now is becomes the 0, and we are going to substitute the a by the 0, because for the system to be at rest or to be at equilibrium, the acceleration is 0. And I'll post the answers in the description below. Thanks for watching, and you can enroll with us. Our number is 7660608201, and write UB BW, and we also offer online lectures.